What is inverse kinematics? Imagine you want a robot's hand or a video game character's foot to move to an exact point in space. You don't want to program how much each joint, elbow, shoulder, wrist, has to bend separately. You just want to tell it, go here. That is precisely what inverse kinematics, or IK, does. It's the mathematical technique that solves the motion control problem in reverse. Instead of knowing how much each joint moves to see where the endpoint lands, that's forward kinematics. Inverse kinematics does the opposite. Inverse kinematics takes the desired final position in space and automatically calculates all the angles and rotations that the intermediate joints must adopt to reach that point. Think of a robotic arm in a factory. The engineer only enters the coordinates of the welding point. IK translates those coordinates into a set of precise instructions for the motors of every joint in the robot. Or consider 3D animation. An animator places a character's foot directly on a step. Inverse kinematics ensures that the knee and hip bend realistically to maintain balance and posture, without the animator having to adjust them. The big challenge with inverse kinematics is that there are often multiple solutions to reach the same point. A robot might be able to grab an object with its elbow up or down. The algorithm must be smart enough to choose the most efficient solution, the one that saves energy, or the one that avoids crashing into obstacles. Essentially, inverse kinematics is the key to making articulated systems move intuitively, realistically, and efficiently.